Welcome back to Step Electrical friends. Now we are here to discuss on nodal analysis, and this is the part 4 of nodal analysis, and in this part we will discuss on type 3 circuit. As you can see here that this is a circuit. In this circuit there are current sources along with voltage source. But as we have discussed earlier in the previous video that the voltage source must be in series with the resistance. But in this figure you can see that there is no series resistance with the voltage source. So we can conclude that this voltage source is not transformable into current source. And one thing, the voltage source lies on the circumference of any loop. And also it is involving the reference node. It is a circuit in which there is a voltage source, but the voltage source is not transformable into current source, and the voltage source lies on the loop of circuit. Also the voltage source is involving the reference node. So these 3 points are important for type 3 to recognize that this is a type 3 circuit. So in this video we are going to discuss on, first of all we will have the general analysis, then we will solve a numerical and verify this numerical using circuit lab. So now let's have the general analysis. As we see, this is a figure and this is the circuit, type 3 circuit. Now first of all we will assume that A, B, C, D are the 4 nodes, and so let's plot it, and there A, B, C, D are the 4 nodes. Now we will consider D as the reference node, so let's ground it, and we will also assume VA, VB, VC and VD with the voltage of the nodes A, B, C and D respectively. Now one thing that you have to notice is that in type 1 and type 2 we have 4 nodes, but 3 nodes were unknown. And now you just think the one D is known here, that is VD is reference node, so VD is equal to 0. But the next one here, the VS, now the VS is connected with this node A directly, so we can say that VA is equal to VS. So only VV and VC are unknown voltage. So here VV and VC are unknown, and if there are 2 unknown values, then we require only two linear equation. So what we can conclude that we will only apply KCL at node B and node C. Friends, it's a request, if you found this video helpful and interesting, please like this video and subscribe this channel if you haven't subscribed this channel yet. So let's apply KCL at node B, and so first we will remove the branches and elements. Now we'll get this. I won't remove this VS. Why? Because VS is nothing, just the voltage of node A. So let it remain connected with node A. Okay, and now one thing that we will write KCL, that is the current through R2, R3 and R4 is outgoing current from the node B, while I2 is the only current entering the node B, as we have done in the previous videos. So we can write IR2 plus IR4 plus IR3 is equal to I2, and IR2 equals VB minus V upon R2 plus IR4 equals VB minus 0 upon R4, and IR3 equals VB minus VC upon R3 is equal to I2. Since VA equals VS, we can replace VA by VS, and we write the equation as VB minus VS. Instead of VA we write VS, and so this is the equation first. Now it's time to apply KCL at node C. So let's apply KCL at node C, and before that let's remove all the element and branches that have no concern with node C. So let's remove. As we remove, we get this, and now here R3, R5 and R6 are the current through R3, R5 and R6 are the only are assumed as the current which leaves the node C, while I3 is the only current that enters the node C. So let's write IR3 plus IR5 plus IR6 is equal to I3, and on replacing with its equivalent value using the Ohm's law, I equals V by R, we will write VC minus VB upon R3, VC minus VB upon R3, R5 as VC minus 0 upon R5, and IR6 as VC minus V upon R6 is equal to I3. As we know that VA is equal to VS, so we can replace VA by VS, and the equation becomes VC minus VB upon R3 plus VC minus 0 upon R5 plus VC minus VS upon R6 is equal to I3. So up to now we have got 2 equations, and now on solving these 2 equations we will get the value of VV and VC, which is the unknown voltage for the nodes B and C respectively. Okay, so this is all about the general analysis of nodal analysis for the circuit containing voltage source along with the current source, and the voltage source is not transformable into current source. The voltage source is lying on the circumference of the circuit as well as lying on the circumference of any loop, and the next one is the voltage source is involving the reference node. So there are three things that you have to think of. So this is a numerical problem. In this numerical problem we can relate with our model, that is type 3, that there are two current sources and there is a voltage source, and this voltage source of 20 volt which is not transformable into current source. Okay, so to solve it, first of all we will assume ABCD with the nodes where D is the reference node as we have done in the earlier parts, and let VA, VB, VC and VD with the voltage of the nodes A, B, C and D respectively, where VD is equal to 0 volt and VA equals 20 volt. Why VA is 20 volt? Because there is no any elements in between this 20 volt and voltage at and node A. That's why we can say that VA equals 20 volt. Okay, so there are only two voltages, that is the node voltage V, node voltage at the B and at C are unknown. So we will apply KCL at only two nodes, that is at node B and at node C. So on applying KCL at node B, we can write I4 plus I5 plus I8 equals 5. I4 plus I5 plus I8, and replacing the value of VA with 20 volt, we will get this equation 0.575 VB minus 0.125 VC equals 10. So this is the first equation. Once we apply KCL at node C, we will get I8 plus I6 is equal to 8, and on replacing the value of VA by what, 20 volt, and on simplifying we will get minus 0.125 VB plus 0.4583 VC equals 11.33. This is the second equation. And now on solving these two equations, we will get the value of VB and VC, that is VB equals 24.2 volt and VC equals 31.32 volt. I have solved it using calculator, so you can use calculator to solve linear equation. So it is easy. Now let's verify our result with the help of circuit lab. So this is the circuit that we have solved, and now I have also drawn this circuit in the circuit lab. Okay, and for proper examination and verification, let's write the result we have obtained. So this is the result, that is VB equals 24.2 volt, VC equals 31.32 volt. Sorry, this is 20 volt. Why? Because this is directly connected with this node A. That's why it is correct. Okay, this one is node V is 24.2 and here in result 24.2. So both are correct. Again here we can see that it is 31.33 and here it is 31.32 volt. So our result is exactly equal with this result shown by this circuit lab. So we have completed this numerical. So we have completed the general analysis and solution of numerical and verification of this numerical with the help of circuit lab. Okay friends, thanks for watching this video till the end, and if you have found this video interesting and helpful, please like this video and share this video with your friends and drop your valuable comments in the comment box. And even if you haven't subscribed this channel yet, please subscribe this channel.